Hi, and a good day, everyone. I hope you had a breather from your previous hectic weeks and that you are refreshed and ready to continue with the rest of the semester. This is Lecture 7, Part 1 of Trophic Adaptations of Mammals. When we talk about trophic biology, this relates to feeding and nutrition, and we have three general types of mammals: herbivorous, carnivorous, and omnivorous mammals. For herbivorous mammals, they eat plant matter, and specialized mammals include folivorous or leaf-eating mammals, nectarivorous, feed on nectar, frugivorous, feed on the flesh of fruits, granivorous, feed on grains or seeds, and graminivorous, feed on grass. Carnivores eat meat, and specializations include those that eat insects or arthropods or insectivorous mammals, those that feed on worms, vermivorous, those that eat fish or piscivorous mammals, and those that eat ants or termites or myrmecophagous mammals. Omnivorous mammals eat both plant and animal matter. Mammals exhibit heterodonty due to the presence of different kinds of teeth. Incisors are for cutting or nipping, canines are usually sharp and are used for puncturing or tearing, and the cheek teeth, consisting of the premolars and molars, are used for chewing. Incisiform teeth have a single cusp, example the incisors and canines, while molariform teeth have multiple cusps. Those are the premolars and molars. In terms of teeth replacement, there are two types: diphyodont and polyphyodont mammals. Diphyodont mammals have two successive sets of teeth, like what we have, right? Initially, the deciduous or the milk teeth, and consecutively the permanent set. Polyphyodont mammals have teeth that are continually replaced. It's a shared character with other vertebrates, such as reptiles and fishes. In contrast with most mammals, elephants, manatees, kangaroos, and mole rats are unusual in being polyphyodonts. The dental formula describes the number and arrangement of teeth in mammals. It is written as an expression of the number of each type of tooth in one side of the upper jaw over the number of teeth in one side of the lower jaw. The letters correspond to the type of teeth: I for incisor, C for canine, P for premolar, and M for molar. So for the dog, there are 3 incisors, 1 canine, 4 premolars on the upper and lower jaws, and 2 molars on the upper and 3 on the lower jaw. And when this is multiplied by 2, gives a total of 42 teeth in dogs. The number of teeth varies, and not all mammals have all 4 types of teeth. Like here, there are no canines. The wide gap between the incisors and the cheek teeth is called the diastema. So this is not a rodent because you see there a set of secondary incisors. So this is a characteristic of lagomorphs. Members of the order Diprotodontia have a pair of large procumbent incisors on the lower jaw, a common feature of many early groups of mammals and mammaliforms. The diprotodont jaw is short, as seen here in Petrogalli brachiotis or the rock wallaby, and has no lower canines. Polyprodont mammals, on the other hand, are characterized by having multiple incisors. This includes the opossums, like this one, the Didelphis virginiana, or the Virginia opossum. In Colobus, The biting edge of the four lower incisors have become serrated with as many as 15 tines each, acting like teeth of a comb, right? Or termed as pectinate, while the canine acts more like a molar. These incisors have been hypothesized to function in both feeding and grooming. By looking at this photo here, you would also think that they might not have upper incisors. But actually, the upper incisors grow at the side of the mouth, leaving a toothless gap at the front of the jaw. Procumbent teeth project forward from the tips of the upper and lower jaws and may function for food procurement and bark gouging. Vampire bats have few teeth because of their liquid diet, but they have razor-sharp teeth. These bats are also equipped with heat sensors on their noses to point where warm blood is flowing on their victim's skin. After putting the bite on an animal, the vampire bat laps up the flowing blood with their tongue. This is a harpy fruit bat, Harpionicteris whiteheadi, which is endemic to the Philippines. One of the distinguishing features of this bat is the presence of secondary cusp on the upper canine and two on the lower canine. In some mammals, some teeth are elongated to form tusks. For example, long spiral tusk of the male narwhal is one of a pair of canine teeth positioned horizontally in the animal's skull. In elephant, the tusks are actually teeth. They are elongated incisors. Herbivorous mammals usually lack canines, and as mentioned earlier, they have this gap, the diastema. However, some may still have canines and also that gap. This musk deer is an herbivore, and the male's elongated canine teeth form saber-like tusks, which they use in territorial disputes or when competing for mates. The normal growth of the upper canine in the babirusa involves the rotation of the alveolus, or the socket of the tooth, in a subcutaneous median plane to bring the tooth to point first rostrally and then progressively in a dorsal direction. The tooth tip then grows out of the alveolus, or the socket, and pierces through the skin lateral to the nose, its curled tip pointing caudally. As it elongates, the axial curvature is reduced, lifting the tip of each canine tooth along the median plane of the skull, up and over the nasal and frontal bones. Aberrant canine tooth growth, however, may lead to it eventually growing into the eyes and causing blindness and death. From the study of MacDonald in 2018, here, showing the dorsal view of a Sulawesi babirusa skull, you can see that the maxillary canine teeth, or both of the maxillary canine teeth, have grown to the right side of the head rather than to the median plane. And below, showing a normally grown left maxillary canine tooth and an aberrantly grown right maxillary canine tooth. There are very few venomous mammals like members of Chiroptera, the vampire bat, Monotrimata, the platypus, and Primates, the slow and pygmy loris, and in the Eulipotyphla, the Solenodon, and some shrews. Their venom delivery system varies, and here in the Solenodon, the deeply grooved lower canines aid in envenomation. So you have seen the vampire bat a while ago, and again for vampire bats, their sharp canines pierce the skin, and the secretion in their saliva, consisting of draculene, prevents the blood from clotting. The cheek teeth provide valuable information on the feeding habits of mammals. teeth of living marsupials and placentals evolved from the tribosphenic type of teeth. In the tribosphenic teeth of the upper jaw, the three main cusps are the protocone, paracone, and metacone. The Zalamdodont is a modified tribosphenic teeth. Zalamdodont molars have three cusps, one larger on the lingual side and two smaller on the labial side, joined by two crests that form a V or a lambda shape. This is found in golden moles and solenodons. In the Dilambdodont, there is a well-developed ectoloph that is W-shaped. At the bottom of the W is the metacone and the paracone, and the protocone sits apart. Examples are shrews, moles, and many insectivorous bats. In the quadrate tubercular or euthymorphic molar, there is an additional fourth main cusp, or the hypocone, in the upper molar. It's located on the lingual side of the tooth posterior to the protocone. So it results in a more or less square surface. Examples are hedgehogs, raccoons, and many monkeys. Modifications may include the addition of small cusps called connules between the larger ones. So for example, a paraconnule found between the paracone and the metacone. For example, here in the red panda. Lophodont teeth are easily identified by the differentiating patterns of ridges or lofts of enamel interconnecting the cusps on the crowns. Present in most herbivores, these patterns of lofts can be a simple, ring-like edge, or a complex arrangement of series of ridges and cross ridges. Lophodont molars have hard and elongated enamel ridges called lofts, oriented either along or perpendicular to the dental row. These are common in herbivores that grind their food thoroughly. When two lofts form transverse, often ring-shaped ridges on a tooth, the arrangement is called bilophodont. This pattern is common in primates but can also be found in lagomorphs and some rodents. Extreme forms of lophodonty in elephants and some rodents is known as loxodonty. So they have loxodont teeth, which are like old-fashioned washboards. The African elephant belongs to a genus called Loxodonta because of this feature. In the solenodont teeth, or molar, this increases the number and size of the animal cutting surfaces. The primary cusps are elongated in an antero-posterior direction. This is found in families Cervidae and Bovidae. Bunodont teeth have low rounded cusps. So this is similar to our molars. And these are found in species with broad diets, such as hominids, bear, raccoons, and pigs. Secodont teeth, or carnassial dentition, is found in flesh-eating mammals. In the secodont dentition, the molars have tubercles that have cutting edges. So the carnassial teeth, which are found in carnivores, are actually the fourth upper premolar and the first lower molar in the jaws of many, but not all, carnivores. They are enlarged and blade-like, and they function for slicing and chopping. There are also mammals that are termed as edentulate, wherein teeth serve little or no function. They have few or no teeth at all. Armadillos have small teeth and with their long, sticky tongue catch ants, beetles, termites, and other insects after digging them out of the ground. Anteaters have no teeth at all and feed almost exclusively on ants and termites, whose nests they rip open with their powerful forelimbs and claws and then ingest them with their sticky tongue. So this is the end of part 1 of the lecture. Watch out for part 2 of trophic adaptations this week and also the learning activity which I will post on Friday. Thank you for listening.